Okay, let's recall inequalities in one variable. They looked like things like 2x plus 3, let's say, greater or equal to 7. In one variable, there was only an x. I would isolate the x. If I needed to, I would flip the inequality. If not, like this case, I would just leave it as is. And then I would graph it on the real line. In this case, the solution would start at 2, and then it would be everything to the right of 2, with the value 2 included because of the equal sign. So the solution would be everything to the right of 2 in interval notation, 2 to infinity, let's say. This was inequalities in one variable. Now we're going to look at inequalities in two variables. Let's start off when a solution is possibly given to us. It is an inequality, it's in two variables, and the question is the ordered pair negative 2, 3 a solution to this inequality? So I'm just going to go plug in the x and the y value and see if I get a true statement or not. And it looks like I get negative 4 plus 9. Is that greater than 6? And it looks like it is a no, because 5 is not greater than 6. So if something is given to me, I just put it in and see if it is a solution or not. But our goal is to be able to get all the solutions of this inequality, and that's going to require a little bit more work. So how do I display all the solutions of this inequality? Because right now I have found this one doesn't work. Maybe they'll give me another one, and that'll be a yes because it'll give me a true statement. But how do I give a sense of all the solutions of this inequality? Well, it requires us to graph the line or the border that this creates, and then also do the shading where the solution might be, kind of like we did the shading here in one variable in one dimension. We would have to do that in 2 dimensions for this problem because there's 2 variables. So we're going to shade the solution for this inequality on the xy plane or the Cartesian coordinate system. So I'm going to take this line right here, or the inequality, 2x plus 3y greater than 6, and I'm going to isolate y because that's the way I like graphing lines. I want them in slope-intercept form. I don't have to flip the inequality because I'm not dividing by a negative. Now I have what is called the border of the solution. So I have this, I can just focus on this. This looks like mx plus b with a y-intercept of 2. Start on the y-axis at 2 and a slope of negative 2/3. So from there I go down 2 steps and 3 steps to the right, down 2 steps, 3 steps to the right, or I can go up 2 steps and 3 steps to the left if I want to. And that's going to create sort of the border of the line that's going to tell me where the rest of the solution may be. Now, since it says x is greater than this line and there's no equal sign with it, I'm going to have a dotted line. So keep in mind, if there's no equal sign, kind of like we used to have parentheses indicating that that's sort of where we get to but not exactly get there. If you have no equal sign with your inequality, the line that you're going to draw is going to be dotted, which means it's just the border, not part of the solution. Then I look at the statement y is greater than negative 2/3 x plus 2. So if I'm standing on this line, let's say I like usually standing right on the y-intercept. In order for the y's to be bigger, would I have to go up or down? Well, if I'm standing right here on the line, one particular place, let's say right here on the y-axis, on the y-intercept, in order for me to have this statement be true and get y's bigger, I would need to go up. So the solution is everything shaded above this line is going to be my solution. Any ordered pair I pick in this region above the line is going to satisfy this inequality. For example, if I pick, let's say, the ordered pair right here, 4, 3, and I put it in my original inequality here, 2 times 4 plus 3 times 3, is that greater than 6? That's going to give me 17, which is greater than 6. Any ordered pair in this region is going to work in the inequality. On the other hand, any ordered pair in the bottom region will not work in my inequality. So I like shading right away by looking at the inequality sign. The other method is just pick an ordered pair either above this line right here or an ordered pair below the line. If you get a true statement like we did here, you shade that side. If you get a false statement, you shade the opposite side. So in this case, if I had picked an ordered pair here, for example, and gotten a false statement, I would have decided that side down here is no good. I have to shade above the line, which is the other side. But I always like isolating the y and then shading up or down depending on which way the mouth of the inequality opens. If it opens towards the y, I always shade above the line. Let's go look at another example. Graph the solution to this inequality. Again, I'm going to isolate the y value because I like graphing in slope-intercept form. Divide everybody by 3, and still I don't have to flip the inequality. I have a third x plus 1, so this is an mx plus b form with a y-intercept of 1 and a slope of positive 1/3. So I go to the y value of 1, and then with my slope it tells me to go up 1 and 3 to the right, or maybe down 1 and 3 to the left. That should be enough dots to get the line. And since I have an equal sign with my inequality, I make a solid line. So my solution actually includes this border. And again, I go and I focus on which way the mouth of the inequality opens. It says y is bigger than this line. So here's my line, that's the border. And I'm going to stand right here. I like standing on the y-intercept usually for these. And if for y to be bigger, I must go up and include all ordered pairs above the line. So the solution is everything above the line, including this border because it's included solid line. Next example, graph the solution on the xy plane, and we have two special cases. The first one is x is less than or equal to -1. So remember, recall, if you looked at x equal to -1, it was going to be a vertical line with an undefined slope. So I'm going to compare this to the line x equals -1, which goes through -1, and it's a vertical line. And since there's an equal sign with my inequality, this border is going to be a solid line. Now it says, look at what the inequality says. It says x has to be less than -1. So I'm going to end up shading everything to the left of the line x equals -1. So the solution is everything to the left of this line. Let's go to part B. It says y is less than 2. Again, recall, y equals 2 is a horizontal line with slope 0 going through the y value of 2. So I'm going to make a horizontal line through the y value of 2. And then notice what the inequality says. It says y has to be less than 2. So I'm on this border. I should actually make the line dotted because there is no equal sign. Remember, if there's no equal sign, my line through the y value of 2 has to be a dotted line, not a solid line. Now the shading, it says y has to be less than 2. So if I'm standing on the border right here, going up makes the y's bigger, going down makes all the y's smaller, and since y's have to be smaller than 2, my solution is below that line. Now when we look at a system, remember it includes two or more equations or inequalities. A system of inequalities for us includes two of them, and the solution will be wherever the shaded regions overlap. For example, it says graph the solution to y is greater or equal to 2 and y is greater or equal to x. So I have two things now to worry about and graph. So let's go and look at the first one. The first one is a special case. Think of it as y is equal to 2. It's going through a horizontal line, like the previous example. And I am making it a solid line because of the equal sign. And it says y is greater than 2, so I'm going to shade everything above. That's the first piece. The next piece is an equation of the form mx plus b, where I really have 1x plus 0 if you think about it. So the y-intercept of this guy right here is 0, and the slope is 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, or down and left, down and left. And this too is a solid line because it includes the equal sign. So there's my line, includes the border as part of the solution. And let's see what it says. It says y has to be, again, bigger than this x line. So if I'm standing on, let's say, the y-intercept of that line, in order to make y's bigger, I have to go up, but not down. So I'm going to shade everything above that line, ignoring everything else. I just focus on that slanted red line, and I shade everything above it. Now the solution is the shaded region that they have in common. So on MyMathLab, you would have to actually know where the solution is, then click that portion with the bucket to shade it. But on here, I'll go ahead and make the solution in purple. So this they have in common. All of this is what they have in common. And that's where my solution is. So this yellow by itself is not the solution, and the green by itself is not the solution. It's everything where they have in common, including the borders, because they are solid lines. Again, graph the solution to the system. So I have two equations, both of which I have to isolate the y value for, or the y variable, and I get y is greater than negative 2x plus 4. That's the first equation. Let's go do the same for the second, and the second one is important actually, because in the process, pay attention, we're going to divide by a negative 1, and remember what happens when you divide by a negative 1, the inequality actually flips. So I get a positive x minus 1, so the slope is 1 over 1. So I got my first line simplified in y equals mx plus b form, and the same thing for the second line. Again, pay attention to how I flip the inequality because I divided by a negative. Now I'm going to go graph both lines. Y-intercept 4, 1, 2, 3, 4, slope of negative 2 over 1, so down 2, 1 to the right, down 2, 1 to the right, and it is going to be a dotted line. It's kind of crooked. The other one, y-intercept negative 1, and a slope of 1 over 1. Actually, let's not do that. Let's go figure out our shading before we graph the other line. And I'm going to go make this a little bit straight too. So notice it says for this one, y is greater than this line. So here I am standing on my border, the line, and I like standing on my y-intercept, and if it says y is greater, I just go up instead of going down. So I go up, and everything above the line is my solution. Same thing, let's go look at the second line in green. We have the y isolated. I'm going to go graph it first. Y-intercept negative 1, slope of 1 over 1, 1 over 1, 1 over 1, and again it's a dotted line because there's no equal sign. So there's my dotted line for the second line. And I'm going to go do the shading in green. It says y has to be less than this dotted line right here that I just got. So I like standing on my y-intercept of negative 1, and then I just say, well, if I go up, y's are going to be bigger. I have to pick all the y's that are less than this border, so it has to be everything below that line, the second line that I drew. And then the solution is whatever they have in common. So I go in purple and say the solution is, looks like somewhere in quadrants 1 and 4. Everything they have in common, not including the borders because they are dotted. So any ordered pair that you pick in this region will work for both inequalities. Any ordered pair in the other three parts will not work for the inequalities. So again, solution is what they have in common where they overlap.